Good afternoon. This is Frank Marisick, President of EE Reports and co-chair of the New York City 2030 District. Welcome to our Advanced RTU campaign webinar sponsored by PaceControls. The highly successful Department of Energy Advanced RTU campaign is run by Waypoint Energy. Today, we're going to share with you information and resources on how you can best optimize your existing rooftop units and what you need to know about replacing your old RTUs with new high-efficiency ones. We're also going to hear about the robust Con Edison incentives that are available for RTU customers by their program manager, Wildan. Our two presentations will last about 30 minutes in total. Afterwards, we'll have a Q&A session, so please post your questions in the box below at any time. This webinar is being recorded and we'll be sending out the link before the end of the week. This presentation is also available in the handouts box below. A little background on the 2030 districts. The New York City 2030 District is a member of the National 2030 Districts Network, a nonprofit volunteer organization dedicated to dramatic reductions of greenhouse gas emissions from buildings and cities. The NYC 2030 District is a public-private partnership committed to creating high-performance buildings that increase marketability and profitability for property owners. The mission of the NYC 2030 District is to be the dynamic energy, sustainability, and resiliency resource, helping all New Yorkers reach our goals. The 2030 districts are active in 20 cities nationwide with over 410 million square feet of commercial space. 3 years ago, New York committed to reducing citywide carbon emissions 80% by 2050. The framework included three components: cut building energy use in half, green the grid, make the grid carbon neutral, and electrify systems to reduce fossil fuel use in buildings. To help the city and our stakeholders, the NYC 2030 District is currently focusing on the green boxes below. As you can see, rooftop units are on our list. The NYC 2030 District offers free services to building owners. Our number one goal is to generate demand to get projects done. We partner with local leaders, and we're currently in downtown Brooklyn and downtown Manhattan. If you want more information, are looking to be a volunteer or sponsor, please email me, frank@nyc2030.org. And now we want to get to know a little bit about you. So if you can please answer a few of these questions here, this will be most helpful for us. And a few more questions for you, if you don't mind. All right, let's get started. It's a 93-degree day in New York City, and there are lots of RTUs cranking out there. Sarmaid Konchkov is an associate at Waypoint, responsible for the execution of multiple government, utility, and commercial real estate energy efficiency programs. She has extensive experience in market transformation, energy efficiency, and data analysis. At Waypoint, Sarmaid co-leads the Department of Energy's Advanced Rooftop Unit campaign and also leads the execution of Waypoint's Utility Connect program, assisting clients in assessing and analyzing energy data across large commercial real estate portfolios. She holds 2 BA degrees in global economics and environmental studies from the University of California, Santa Cruz. Welcome, Sarmaid.
Thanks, Frank. Again, my name is Sarmaid Konchkov with Waypoint Energy, and Waypoint is contracted with the National Renewable Energy Laboratories, or NREL, to implement the Advanced RTU campaign. So what is the Advanced RTU campaign? It's a national market transformation initiative that the Department of Energy's Better Buildings Alliance started in 2013. It's co-organized along with ASHRAE, RELA, the Retail and Industry Leaders Association, and FEMP, Federal Energy Management Program. for the purpose of promoting the replacement of RTUs with advanced units and retrofitting RTUs with controls in commercial buildings, along with quality installations and quality maintenance, and the campaign's new focus towards advanced automated fault detection and diagnostics, or AFDD, and intelligent controls. You can find more at our website, www.advancedrtu.org. You can go to the next page, next slide. First, let me preface that folks are encouraged to join as participants and supporters. So participants are commercial building owners or managers who are looking to implement advanced RTU measures on their buildings. And supporters are organizations like utilities, contractors, manufacturers, and service providers who support and promote these measures and efforts. So what are the benefits of joining the campaign? So you can view this as a business opportunity. Our organizations can gain credibility from joining and from the experience of being part of a national campaign. We also have loads of resources that you and your organization can leverage to evaluate savings opportunities. Some of our supporters offer discounts that you can qualify for, including, for example, on ASHRAE technical guides. Being a market transformation campaign, we are continuously keeping you updated and in the know on RTU technologies and resources. You can also gain recognition. So we host the annual Advanced RTU Campaign Awards, where folks can be recognized for their various efforts, energy savings, and unique programs. Our most recent Advanced RTU Campaign Awards were just announced a couple months ago, and there's various press and recognition that go along with that as well. And you can also have the chance to participate in case studies to highlight energy savings and unique RTU programs. And above all, you can save energy and money. For example, older RTUs can waste from $1,000 to $3,700 per unit annually, depending on building size, number of RTUs, and type of the building. Next slide. We have a lot of resources on our website, and what the Department of Energy recently did was compile and sort a lot of these resources into 6 separate toolkits for different use types. So we have replacement and retrofit toolkits for both contractors and service providers, as well as utility and efficiency programs. We have a toolkit for lease space tenants. This includes example lease language, case studies, and other resources to help building owners and tenants effectively consider high efficiency RTUs and leases. And we have an evaluation methodology toolkit for building owners and facility managers, which includes a step-by-step method of evaluating and managing RTU inventories and how to make the business case for replacements, retrofits, and quality maintenance practices. So you can click on any of those links there, and this screenshot shows those 6 toolkits with the sorted resources. Next slide. You may wonder if it's better to implement a total replacement or just need to retrofit your units with controls. So if you go to our retrofit or replace page using that link in the slide, you can find a checklist to determine if your property is a good candidate for an RTU retrofit or replacement. And then we also have a step-by-step set of resources built around a streamlined RTU evaluation methodology. So the screenshot in this slide is of a decision tree that you can find in that methodology, in which you can organize RTUs into essentially 4 categories: retrofit, replacement, no action, or needs further analysis, according to the results of the initial inventory and guidance provided in the decision tree. Next slide. Starting the procurement specification stage from scratch may be a bit terrifying. So we have a number of sample specifications to help you identify what your high efficiency consideration should be, whether you're replacing RTUs, retrofitting existing RTUs with advanced control, or specing new RTUs. So if you go to our Find a Product page, you'll see a procurement specification section that lists different specifications for your use case, including high efficiency RTU specifications, and we even have Adidas's RTU procurement specifications to go off as well. Next slide. We just updated our utility incentives database in February, so we have a new up-to-date list of utilities across the states and their associated RTU-related incentives. So this slide here shows a list of our New York specific incentives, including Con Edison, NYC, Orange and Rockland, and RG&E. We'll hear more about that in a little bit, but if you click our link for the utility incentives database, you'll find these incentives and a link to the respective utility incentive page where you can find the incentive values and the incentive process for the incentives as well. Next page. If you need help finding HVAC manufacturers, we have a long list of contractors, manufacturers, service providers, and efficiency organizations to talk about RTU products and measures. If you click on our supporters link and go to our supporters page, you can find this long list and feel free to contact us so that we can facilitate an intro for you as well. Next page. One of our great resources is a business case for proactive RTU replacement. That's essentially early retirement of RTUs. This business case report lays out key elements to consider in making the business case for a proactive, high-efficiency RTU replacement strategy. So, for example, facility maintenance staff and building engineers who are responsible for energy management of their buildings can utilize this resource to help make that business case. So you can click that link below, and this slide shows screenshots of what that report looks like. We can go into that in a little bit if you hit the next slide. What are the benefits of proactive RTU replacement? Well, first of all, there's an avoided cost of a planned replacement compared to costs associated with emergency replacements. This includes loss of service during critical business operations, high service fees from the installing contractor, and lost opportunities for system optimization. Along those lines, you can allow time for proper planning, design, and getting that best value. And there are qualitative benefits as well, such as avoided maintenance calls and improved indoor comfort by temperature and relative humidity control, and even reduced noise. You can eliminate R22 refrigerant from your inventory. Then above all, you can reap in energy and peak demand savings. Next page. Another thing you can find in the proactive business case is an example of early retirement that we created. This one's in a large retail store. So let's say this retail store has 5 12-ton, 15-year-old units. Each unit was at an 8.7 EER rating and has since degraded to 7.3. All of them are constant speed and have R22 refrigerants. So the store is assessing whether or not a replacement of RTUs can be cost effective. So let's say that replacement will be the replacement of 5 RTUs at 10 ton. They'll be right sized. They will be at 12 EER, and we prefer to use IEER, so 13.8 IEER rating. And R22s have been eliminated, and instead they have R410A refrigerants. So again, we're assessing whether or not this replacement can be cost effective. Next slide. So this report has a nice table that shows the upfront costs, the benefits, and financial metrics of this replacement, and we'll just walk this through to give you an example of what your building can save. So the upfront costs include capital costs, so the design and analysis, and then the cost of purchasing the RTU. So let's say $8,000 a unit. The installation and building upgrade costs, there may be a need to reinforce the roof, for example. So let's say $20,000. And there will be utility incentives available. So let's say $1,640 per unit for the incentive. Maybe other financing options, and there's a scrap value. So this store can sell each of the old RTUs for $200, let's say, as scrap for a total of $1,000. So that total for the 5 units comes out to $50,800. There may be post-installation costs and savings. We're looking at 5 years for these examples. The operation and maintenance savings will be about $500 for each unit, and for 5 years that comes out to $12,500 in savings. You may lose a bit of tax depreciation as a result of retiring the RTUs before the end of their depreciation period. That will come out to $1,750. Now, what are some of the benefits? Obviously, we'll have energy savings. For 5 years, that's a total of $38,439. And then additional cost savings is right-sizing the equipment that's included in the price. The avoided emergency replacement cost, which we discussed previously, that can come out to $26,250. There's a benefit of purchasing the units in bulk. Adidas did the same thing, which you can view in the procurement specification. And then there's a benefit of multiple measure packages through an economies of scale installation, which minimizes the number of days spent on labor. R22s are being phased out, and the cost of these refrigerants are increasing as a result of the decrease in production. Now, there are qualitative benefits as well. The air quality and tenant comfort, let's say $2,000 in benefits, and then sustainability values of the store being sustainable, which can also attract in more business because of that sustainability value and effort. And now we also have financial metrics that you can bring back to your facilities to really show building owners and building managers and high-level management what they often look at. So there's an ROI, or return on investment. That's the ratio of the net benefit and the investment cost. That's 52%. The simple payback period, the time required for the benefits of an investment to pay off the initial cost, and that comes out to 3.3 years. And then the net present value, which returns a positive value. And then the internal rate of return, the effective rate of return generated by a flow of costs and benefits over time, and that comes out to 16%. Next page. And that's it. Again, my name is Stormy Konchkov. You can reach out to me with the email there with any questions you have. And again, we encourage folks to join the Advanced RTU campaign as a participant or supporter using the advancedrtu.org link and signing up through there. Thank you.
Great. Thank you, Stormy. That was most helpful and very educational. And I would like to now thank PaceControls for sponsoring this webinar. I'd like to introduce Tom Mills. Tom is the president of PaceControls, a DOE grant-funded smart grid technology company and developer of the Pace plus Pace Cloud suite of cost-effective wireless modules to bring IoT monitoring and energy savings to what heats and cools the world, based at the Philadelphia Navy Yard. With the rest of the PaceControls team, Tom manages PaceControls joint product development and strategic partnering with global OEMs, as well as its energy-efficient retrofit work with large utility programs and property management clients, with over 20,000 installations to date across North America. Tom has a degree in chemical engineering from Princeton and an MBA from Morton University, and it serves as a U.S. Navy submarine nuclear engineering officer. Whoa. Okay. So Tom is joined today by Antoine Cannon, the program manager for the Willdan Group, which manages Con Edison's commercial direct install energy incentive programs. Antoine graduated from Yale with a double major in economics and East Asian studies. Prior to Willdan, Antoine worked as an energy auditor at EME Group. At EME, he managed NYSERDA's small business energy audit program for the majority of the NYC metropolitan area. Antoine has also worked as a strategy, marketing, and sustainability consultant for various nonprofit and for-profit firms. He sits on the executive committee of the NYC chapter of the Sierra Club, and he is the co-chair of the Manhattan Borough President's Go Green Initiative Sustainable Business Committee. Okay, gentlemen, take it away.
Thanks very much, Frank, and thanks, Stormy, for that great introduction. We're excited to be part of the Advanced RTU campaign, and Antoine and I are going to do a duet on this if we can. But that's a great lead-in. And if we go to the first slide, Frank, that'd be great. And for the folks on the call, the first slide is really the mission slide and what we already know. Metro New York has tens of thousands of HVAC and refrigeration units. We're looking at some of those HVAC units down here on Pine Street at Willdan's offices. and they contribute a lot to peak grid loading, and they do cost a lot, particularly if maintenance is an issue and so forth. So what ARC is about is responding to that, and NYCERDA and Con Edison have in particular come up with some really good and compelling programs, and couple in particular we want to talk about commercial direct install. And for that, I'll turn it over to next.
Sure. Next slide, Frank. Thank you. Good afternoon, everyone. Antoine Cannon here with Willdan Energy Solutions. Frank, thank you for that wonderful intro. I didn't realize you were going to go into all that. I did just want to qualify for everybody on the call. I'm actually the Deputy Program Manager. Joe Danielli, my colleague, is actually the manager of the CDI program, which is the program we're here to talk about. So that said, I wanted to take a second before I jumped into the HVAC incentives and just mention that Con Edison does have a wide array of incentives, currently focused primarily on lighting upgrades, but also including refrigeration upgrades and some hot water measures. And we're actually looking to grow that expeditiously. So our first undertaking here is rolling out a suite of HVAC measures, but we'll be looking to roll out heating measures, boiler measures, envelope measures, some plug load measures as well. So be on the lookout. I'd encourage you guys, if you are interested in learning more about this, do feel free to reach out to myself. We'll make sure the contact information is available at the end here. So before we move on to the actual measures, also just wanted to note, historically, as I mentioned, primarily have focused on lighting in these programs, and have primarily focused just on retrofit, sort of swap out type of measures, replacements and retrofits. As we pivot towards the HVAC and air conditioning, both in the heating side, we're also going to be introducing new types of measures, primarily, though not exclusively, focusing quite a bit on control measures. Everything from the thermostat level to compressor controls and burner controls to things where we can optimize the outdoor air, economizing demand control, ventilation, and so forth. So that's going to be a new world for us. And we'll also be looking at O&M measures, operation and maintenance measures, as it relates to refrigeration. We'll hear more about this in a second, but things like charge correction and duct optimization. So, so those are a few new elements here, and also just want to mention, I believe Frank mentioned we'd have a lot of HVAC contractors on the call with us. Our program has primarily been comprised of subcontractors that focus on electrical and lighting upgrades. Now that we are venturing into the new space of HVAC and other more sophisticated measures, we wholeheartedly welcome any HVAC contractor that's interested in extending these incentives and these offerings to their customers to join. As we'll discuss in a second, the incentives are pretty lucrative, and these are many things that you might already be recommending. So it'd just be a good opportunity to extend some discounts and some incentives to your customers. So that said, Frank, let's go ahead and go into the next slide. So this is the long and short of it, team. It's as it relates to HVAC, these are our 10 new measures. These aren't the only ones that we are looking to roll out, but these are the ones that are available as of now. If you guys look at the columns here, I like to categorize things. That's, I think, makes it easier for us to wrap our minds around it. So if you notice, I created a category column, and so the first two measures relate to replacing equipment. The next two relate to retrofitting, in this case, the motors. Following two are operations and maintenance measures. And the bottom four are all controls measures, right? So we'll take a second and just touch on each of these, but wanted to bring attention to that so you guys can kind of think about what buckets to put these into. In terms of replacement, so certainly here to talk primarily about RTUs, but I do want to mention that we have an incentive for replacing PTACs as well as PTHPs. The ones that go through the walls, right? You'll notice that if you look to the column on the right, the incentive amount varies whether it's an air conditioner or a heat pump within the same category, right? So it's $100 for a PTAC versus $125 for a PTHP. As folks can imagine and intuit, the reason that is the PTACs, the heat pumps run longer because they're doing the heating side as well. Thus consume more, and thus when they're upgraded can save more. So there's more value to that from an energy savings perspective. So that is mirrored if you look down to the second row here as we look at unitary equipment. So if you were to replace a unitary air conditioner, whether it's split or an RTU, you'd get $250 per ton. Whereas if it happened to be a heat pump version of the equipment, we can do up to $400 a ton. So just staying with these two for a second, anybody that's been involved in the energy efficiency program space might be familiar with the I don't know if it's famous or infamous TRM, the Technical Reference Manual, the resource manual, which specifies the energy savings methodologies for a lot of these upgrades. If you're not familiar with it, I encourage you guys to look into it. It's a really interesting resource. But I'll just mention that within that resource, it specifies 3 different ways that we can get upgrades done. And we just heard about one of them from our prior speaker, the early replacement, which is advantageous if you guys can replace units early when there's a more efficient option. But there's actually also an option where the unit is gone beyond its useful life, which we call extended life, which also actually has favorable economics from a savings perspective. So to be sure, the 3 categories of upgrades are going to be early replacement when it's before the 15-year useful life, burnout replacement when it's right around 15, 16, 17 years, and then extended life when it's more than 20% beyond its useful life, so right around 18 plus years. And those will be slightly different savings calculations, but what is true for all of them is that the incentive stays the same. So the paybacks are affected, but the incentive is not. It does get a little nuanced, so that I am happy to kind of work with anybody that is looking to replace these, happy to do a site visit and put together the proposals with you guys. I'm assuming folks might have questions now. I believe Frank is going to be fielding and screening those. So Frank, please feel free to interject if you have anything to inquire about. Measures 3 and 4, guys, retrofits. This all has to do with making our motors controllable. So for smaller motors, we can replace them with EC motors, electronic commutated motors. That's typically for motors of 1 horsepower or less. Larger motors, where we want to retrofit and add some controllability, can make use of VFDs, variable frequency drives. And again, you note the incentive here to the right. VFD is about $75 a horsepower. The measures 5 and 6, the O&M measures, we can correct the charge on the units, right? In fact, actually, one of the benefits of the PACE control that we'll be hearing about is that it actually provides a snap diagnostic that can provide an estimated efficiency for the unit, which can then inform the need or the lack thereof for charge correction and other types of maintenance procedures. So our idea is to get some controls in the system, see how it's performing, and then see if O&M is appropriate for that unit. Similarly, it's all for naught if the cold air does not make it to its desired space, right? So we want to make sure that the ducts that are being serviced by these units are properly sealed and insulated. There's actually this can be pursued, independently. You can do them both together. You can just do the insulation if it's already sealed. So that there's a couple different ways we can pursue this one. But really the ones we wanted to focus on and the ones that kind of lead us into the main portion of the presentation are the controls. Again, assuming this is a more sophisticated audience than some of my broader sort of public speeches or presentations, I won't get into the weeds here, but we're eager to promote demand control ventilation. We think that's a really good measure. As folks know, a lot of times fans are being run at full blast when they don't need to be, when occupancy is limited or there is no occupancy. So there's opportunities to reduce the speed of the fans through some CO2 sensors. Economizers, also referred to as free cooling. There's some opportunities there in spaces where we have to cool during the winter. Think of data centers, gyms, places like that. Wi-Fi thermostats, right? So these smart, think of Nest or Ecobee type thermostats where we can control and set programming and do all these fancy things remotely. That's a good one. And actually, we think that the Wi-Fi thermostat goes very well with our 10th and final measure here, which is the PACE control. Now, Tom, I tell you, as I've told everybody else, it's sort of a blessing and a curse because we can describe this control in a lot of different ways. It does a lot of different things, a lot of bells and whistles. But I think sort of the core of where the energy savings are realized, and then the way that we're referring to it is as a smart compressor control that sort of optimizes the cycling of the compressor based on indoor temperatures, windstream temperatures, supply temperatures, and so forth. So yeah, so the smart compressor control, it would be the 10th, and really for us, we'd like to see 9 and 10 go together. We think the smart compressor control that's also monitoring the units, letting us know how much power is consuming, tied in with Wi-Fi, remote accessible controllable thermostat is a really good pairing. So again, I'm sure that was quick. Feel free to reach back out. I'll come back at the end of the presentation with a couple closing remarks, but with that, I'll pass it to Tom.
Antoine. Hi, everybody, and thanks, Frank. Exactly. The what we're excited about, I think, here is with partnering with Con Ed and through Willdan, what we have is a IoT node, smartphone sized, and with everyone having a 4G LTE radio as well as being Wi-Fi and Zigbee capable. And it's the idea, just as Antoine said, it's kind of a green Swiss Army knife. We can go in and establish connectivity with pretty much any HVAC unit, and also through our cloud-based learning software, provide optimization, compressor fan and burner fan operation. The unit itself is about the size of the iPhone 6. It's right next to our laptop here. That's a picture of one of our PACE nodes in top right inside a 2.5 ton split behind somebody's house in New Jersey. So, and even so, you're optimizing the compressor and fan operation. You're getting a supply and return refrigerant temperature, full power. So we're for those who know the measurement and verification jargon, it's an IPMVP option B compliant device. So you're getting real-time monitoring. And you're also, to Antoine's comment about wanting to add in features and options and so forth through Zigbee, which is an open standard wireless protocol. It's well standardized in the industry. You can add zone occupancy or temp sensors, CO2 sensors, so forth, to provide demand control ventilation. So you can build it out. But at the same time, at core, you're getting supply and return temperature, and it's all going up to the cloud, being trended, fault detection, messages being generated. So you're getting connectivity and fault detection as well as savings. And all via the modern miracle of cloud API platforms, talking to platforms, that data can go wherever it's stipulated. So you've got a lot of optionality, including some additional fault detection, but all in one small box that can relatively easily be installed by any HVAC technician or other technician. If we can go to the next slide, that would be great. So really proud again. Want to come back and just as Antoine said, and with Sormay's presentation as well, we're happy to take questions. These presentations will be online, and we will have our contact information at the end of the slide deck. But with the PaceControls Cloud, we're very proud of our science. Really good studies done, over 80 plus IPMVP compliant studies, as I said. Conducted by DOE, under DOE grant, Cal Energy Commission, Intertech ETL, and lots of good science. This picture here shows that, a durability of savings, as it says in the caption, 20% savings, electric or gas, plus the cloud monitoring and fault detection. This graphic is from a 10-month gold standard study that was commissioned by California Energy Commission. Is in San Diego, so you get 10 months of cooling. And as you see, the x-axis is dry bulb temperature, daily dry bulb temperature in degrees Fahrenheit. The y-axis is daily energy consumption. These were heat pumps, and if you fair align through the blue is with our PACE node online, red is retrofit offline. Fair align through those, the independent engineering firm found 18% to 24% savings with absolute maintained set points in a modern flex office manufacturing building with an existing building management system. And that's what we've been able to deliver, and that's why we're really excited to be working with Con Edison. Well, that we can go to the next slide. We'll get through the next couple, then turn back to how you can perhaps participate. Another thing that we can deliver. And at the bottom left is a slide or a graphic that we like that was developed by DOE, Lawrence Berkeley Lab. It's more or less this triangle is kind of what the grid needs to be smart. And so, just as we all know, it needs daily energy efficiency, it needs time of use energy, which is load shifting generally, daily peak load management, and then demand response, real-time demand response is the most valuable. But with the black checks are what we can deliver, and then we can deliver the final check in partnering with technology partners. But bottom line, we have we're very proud of our breakthrough throttle back demand response technology. It does a better job of maintaining temperature during an HVAC demand response event than the traditional methods of really just letting the temperature go up, honestly. And then to varying degrees. This is one picture of our demand reduction technology in action. This is a Hitachi project. And just as an example of the speed of installation, this is not going to be every time, but because we're a low voltage node-based solution, this was a Hitachi project where the gentleman who did the installation hadn't seen us or this system before 9 o'clock in the morning, and by 12 he had the nodes installed in 2 fairly large air conditioning units, one of which you can see behind him, and yet we were able to deliver fault detection and monitoring for this client, as well as the 16% peak kW reduction that you see there. If we can go to the next slide, that'd be great. And so, because we're a durable, low cost, easy to install solution, we're proud to have gotten a lot of traction and work with partners like CBRE, with whom we've worked for 5 years. This is a snapshot of, it's a lot of numbers in there, I'm afraid, but snapshot of an actual CBRE client where we showed 8% whole building savings. This was in Florida on a building that was electric cooling and heating, but this was just for heating. This was just for cooling, rather. So we're actually, for that client, we're with CBRE, we're doing a North America-wide rollout of our really modular energy management system, and now tipping into global. Also a lot of work with utilities as a natural next segue to what to do after the LED programs. So this is on the right is a flyer for our program with NextEra Energy, which is the parent of Florida Power and Light, to its 7,200 commercial and industrial customers across the country. Comparable with Wi-Fi thermostats, comparable with VFDs. Hitachi, obviously, Danfoss make a lot of VFDs, and really we can work with a BAS or without a BAS. Via Cloud API, you can get the data wherever you want, and that again is an advantage. And as Antoine said, as this node is installed, as you're picking up supply and return temperature, full power demand, the technician can actually do a visual inspection of the coil filter and contactors and enter all this, and with 3 quick scores and about 10 minutes worth of work, he can do an HVAC snap, what we call a snap diagnostic, to determine whether or not that unit could use a tune-up. And that's again, makes a big difference. When you've got a technician there, he's got the tools, why not use the opportunity to do that tune-up if it needs it? If we can go to the next slide, and I think we're about ready to turn it over, and it is. I'm just turned over.
Before I jump into this slide, just mention, one thing that's exciting from our perspective is stepping into the world of potentially verified savings, right? Historically, most of the savings have been on projections based on deemed savings values, things like that. And certainly customers are often skeptical about the savings. So it's exciting that with smart technologies, we can now that have power, measurement ability and trending ability, we actually can now clearly indicate to a customer how much each unit's using, and then after turning on the control methodology, we can actually isolate and distill the savings. So an exciting proposition and a new space for us to enter into. This slide really is meant more for folks as we get into the proposal making aspect of it. This is a little snapshot of the calculators that we can provide. So we don't expect that you guys will run these calculations on your own, but we do need your help in collecting the data and populating this so that we can produce an approved calculation and a savings approximation. And just wanted to mention that, sometimes it gets a little nuanced. Folks aren't always that clear on all the terminologies, but some measures where we're looking at upgrades are going to affect the entire system. You notice he's on top. Are going to typically be based on the tonnage, right, or on the number of BTUs that the units are moving. Whereas on the bottom here, you see some measures related to the retrofits of the motors, and those will typically be based on horsepower of the motor of the equipment itself. So again, just some potential sources of confusion. Let's say here on the top left, right, some of the terminologies and some of the data points we want to make sure that we're clear on as we're collecting this data and putting these proposals together. Again, something I'm happy to either coach your team on or work with you, or actually help put this together with you. So not to worry if these are not things you're familiar with. I'm happy to help you navigate that. Frank, next slide. So really from the program perspective, we are ready, set, go. So if you guys have any projects that you guys are already scheduled to move forward with, I would love to meet with you as soon as possible. Make sure we get some incentive for those projects before they proceed to implementation. If there are projects that you are considering, right, we'd be happy to build the case with you based on the incentives and see what we can do. And if you're not sure, we're also happy to come out and provide a survey and try to uncover some of these savings opportunities for you. We have a trained cadre of 20 surveyors we can deploy as needed, so please do feel free to reach out and ask for assistance if it's needed. Here you have some generic verbiage from the website, I believe, the Con Ed website, about how you would get involved in the program. It is important to note that although Wilden is the program manager, we're not the only implementer. We actually work with about 50 subcontractors, any of whom you guys could work with. And it's actually an open enrollment. So if you yourself are a contractor and you wanted to offer these incentives to your customers, we'd be happy to onboard you. There's a few requirements, electrical license, OSHA cards, things like that, but insurance requirements. But again, that's something, if anybody is interested, happy to provide some guidance on that. So if you're a customer, we can schedule a survey. We can help you connect to the contractor, get the equipment installed. And then especially as it relates to PACE and any of these smart controls, we also want to help verify the savings with you. So we're actively looking for partners and folks that might want to pilot these technologies on their sites. We actually are in the process of putting together a proposed pilot for PACE specifically. So if anybody is interested, please do reach out. Frank, go to the next slide. Oh, yep. And just for reference, guys, these are some of the contractors on our current roster of contractors of subs that do work in the HVAC space. As I mentioned, a lot of our contractors do a lot focus more on lighting, but we do have some contractors with broader expertises. So just a short list here for you guys to reference if need be. Frank, I believe that's going to get us here to the end of the presentation, right?
Yes, indeed.
All right. So that's pretty much it for our side. I mean, we could talk about this forever, but if anybody did have any thoughts or questions or wanted to schedule something, please do let us know.
Yeah, so I'd advise everybody to take Antoine up on his offer and have him come to your place and help you out and your customers. So we do have some questions, we do have some time, but I just want to tell everybody that the handouts of this webinar are in the handouts box below, and we will be sending out a link to the webinar once it's recorded as well. So I just want to make everyone aware of that. We do have a question for the non-technical folks here. For novice facility managers, what is the best way to approach the RTU repair and replacement decision tree with limited resources, e.g. poor visibility and traceability of inventory? Anybody want to take that?
Is that something that you'd feel comfortable? Talking about using those toolkit?
Can you repeat that again, Frank?
Sure. Where is it? I'm sorry. For novice facility managers, what is the best way to approach the RTU repair and replacement decision tree with limited resources? Example, poor visibility and traceability of inventory.
Sure. Yeah, so if you want to first have a conversation with the Advanced RTU campaign, we're happy to have that kind of more detailed conversation to discuss your specific building. But this inventory and our pages for the decision tree kind of apply to not only facility engineers but the building manager and owner as well. I think it's important to talk to your facility engineer if you have one, and if not, kind of find blueprints or any sort of inventory that you have to do some sort of walkthrough of your building and so on, to get that initial inventory and identify if your building requires a replacement or controls for your RTUs.
Great. Okay, Tom and Antoine, this should be for you. What's the average savings for maintenance costs after replacing RTUs and using IoT-enabled sensors to monitor temps and use connected sensors to monitor variable speed fans? And use connected variable speed fans. Let me say that one more time. What's the average savings for maintenance costs after replacing RTUs and using IoT-enabled sensors to monitor temps and use connected variable speed supply fans?
Well, yeah, good. You've got a couple of measures there. Do you want to take a
Well, yeah. So
that,
that's a good question, and the answer might be like, what does the TRM say, and then what does reality say? It's a little nuanced, right? So there's at least two measures that you mentioned there: the replacement of the unit, the installation of advanced controls, and then actually the VFDs to make the speed controllable. So we would have to isolate the savings from each one of those and then add them together, and then there'd be some sort of coincidence factor, sort of overlap. Interactive effect overlap. So we would discount the savings a bit. So that one's a bit of a tricky question, right? Because we also don't know if it's a heat pump. We don't know what kind of facility it's in. All these things may actually play a factor into it. So happy to put a proposal together and do the calculation with you, but maybe a tough one to give you a sweeping statement on.
Yeah, I was about to say the same thing. If the questioner wanted to send us our contact information on the last page, the specifics of their situation, as Antoine said, the New York State TRM breaks down the measures differently, and then you kind of have to combine them with coincidence factors. But we'd be happy to tackle that.
But that said, for the pace control, which does a lot of what you're suggesting, right? Not all of it doesn't actually control the speed of the fan, for example. But we, under our current methodology, are recognizing 18% savings on the energy side, on the KWH side, pending MNV, right? So that's hence the pilot and the testing that we're looking to do.
For incentives, the incentives that you saw are pretty significant under the CDI program.
Yeah, certainly. Okay, so may we have another one for you on your decision tree, which is getting some traction here. On your decision tree, are you saying you do not retrofit if the unit is older than 10 years? Can you touch upon that?
I'm not sure if we specify that. It's a case-by-case basis, and really just depends on what the efficiency, how much the efficiency has degraded for the RTUs.
Okay.
We would agree on, if I can interject on that, we would agree on that as well. One of our partners makes the analogy, and it's fair, if equipment is more well maintained, 15 years is sort of an EUL, effective useful life, thumb rule for let's say RTUs and so forth in the US. But if equipment is well maintained, it's a little bit like a human being who's well maintained, right? Their odds are lasting longer with greater greater health are just that much better. So we certainly see retrofit solutions, whether it be VFDs or the like, PACE and so forth, in the 15 to 20 year range, which again it's also hits those sustainability goals. But it does depend on how they've been maintained, right? Yeah.
Yeah, I agree. That 10 years is kind of a rule of thumb. It's really if it's 10 years and all of the other things in the checklist also apply. The efficiency is degraded and constant speed fan control and XYZ. So it's a rule of thumb and something to kind of go by. And if it comes to that 10 to 15 years, it's something to assess a little further.
Okay, great.
Frank, one quick comment on that. I will just mention again from the program side and the TRM side, we can recognize better savings, right, and thus provide a better payback and ROI if the unit's retired before its useful life, before it hits the 15 years, or 20% after its useful life. I know it's quirky, but that is kind of the way that it's framed. So if you're replacing when it's between 15 and 18 years, not going to be able to recognize that great of savings. If you can replace a little early, or if you have an old unit that's kind of the engine that could, but it's ready for replacement, approaching 20 years plus, those scenarios are very advantageous for replacement.
Certainly. Tom, we have a question here. Does the PACE system work with mini splits like hotel rooms?
Oh, that's a great question. With our work with Hitachi, obviously there's a lot of inverter-driven systems. The mini splits are, first of all, small, and second of all, often inverter-driven, so they have an inherent hitch up in efficiency over the vast majority of units that are single speed in North America, at least. It will work on a bang for buck basis. It's better to do mini splits in company with a cohort of other units that may be larger and so forth. On their own, probably not the best fit. Not to say that we're not looking at ways to address mini splits, which are great, and Con Ed and will then have incentives for mini splits themselves.
Actually, take a second and just mention something on that, Frank. So I didn't list mini splits as a type of equipment that we can upgrade because it's technically not offered through our program. But in the Con Ed suite of offerings, there is a mini split specific program. So we're actually doing a cross-selling partnership with that program, the residential program. So yeah, please be advised there is incentives for mini splits as well.
Okay, great. And we have one last question here, which is a long one, so maybe we can suck up all the time we have here. What's the average savings for maintenance costs after replacing RTUs and using IoT-enabled sensors to monitor temps and use connected variable speed supply fans?
I think we touched on that one. That was one where we invited the questioner to maybe send us some specifics of this portfolio, and we'd be happy to do an engineering analysis.
Okay, great. Appreciate that. So I believe that's it. I want to thank everyone being here today and joining us. And again, we will be sending out links to the webinar, and the handouts are still available if you want to download it right now. So thank you, Tom, Antoine, and Sorme, and all of our guests who attended today. Have a great day and keep cool.
Thank you.